we've looked at slope-intercept form. Now we're going to move on to standard form, another type of a way to write linear equations. So before we start, we really need to know what x and y-intercepts are on a graph. So the y-intercept, that's the place where the line crosses the y-axis. So if you have a little graph like this, right here is where it's crossing the y-axis. I want you to think about it. What does x always equal when a line crosses the y-axis? What's the value of x? So no matter where that line crosses, x always equals the same thing. Okay, I hope that you said x equals 0. That's going to be very, very important. At the y-intercept, x equals 0. So teacher says this is important. Okay. X-intercept, the place where the line crosses the x-axis. So this time if we have a graph like this and you have your line, right here would be my x-intercept where it's crossing the x-axis. Okay, and I want you to do a similar little thing about thinking here. Y always equals the same value at that place. And I want to say, hopefully, that y equals 0. I think this is a really important concept. Okay. When we're going to look at standard form, this is something I want you to memorize. So standard form of a linear equation, it is ax plus by equals c. A, b, and c are integers, so they shouldn't have fractions and decimals, but they're numbers. Okay, and a and b are not both 0. Okay, so one of them can be 0, but they can't both be 0. A, b, and c have to be integers. Okay, and then x and y are your variables like normal. So here's an example of an equation in standard form. Negative 2x plus 5y equals 20. Okay, and when I'm trying to figure out an equation in standard form and trying to find the x and y intercepts, I have to remember that for the x-intercept, it's always true that y equals 0. Okay, and for the y-intercept, it's always true that x equals 0. So I'm going to show you a couple ways to solve this problem. So one way is to go ahead and to look at your x-intercept to just go first off and plug in 0 for y. So we're going to have negative 2x plus 5 times 0 equals 20. And so that's negative 2x equals 20, which means x has to equal negative 10. So we already said y equals 0. So it looks like when y is 0, x is negative 10. So negative 10, 0, that's my x-intercept. Okay? And then so to find my y-intercept, I'm going to do a similar manner, but this time I'm going to plug in x equals 0. So I've got negative 2 times 0 plus 5y equals 20. And again, negative 2 times 0 is just 0. So I've got 5y equals 20. And so y equals 4. So remember, x equals 0 in that case, so I've got the point 0, 4. That is my y-intercept. My y-intercept is 0, 4, and my x-intercept is negative 10, 0. Okay, so I usually basically use that strategy, but I use it, I guess, in a little bit quicker manner, where I have my equation here, negative 2x plus 5y equals 20. And I like to think of it as the cover-up method, because when I solve for my x-intercept, y is 0, and notice that the y term just canceled out, so I kind of like take my thumb and I cover it up. So there's that 5y is gone. Bye-bye. And so I'm just solving the equation negative 2x equals 20, which is x equals negative 10. So it's the exact same I did. I just kind of take one little step away and I put my thumb over it, and there it's gone. And then to find the y-intercept, I go, well, that time x is going to be gone, so there, oops, I'm going to take it away. Goodbye, x, and now I just have 5y equals 20, so y equals 4. Most of the time I try to do this in my head as much as possible. Okay, for this one, I want you to try this. Find the x and y intercepts of 2x plus 5y equals 10. Try that on your own, then come back and check. Okay, so again, I'm going to use the cover-up method. This time I'll find the y-intercept first. So goodbye, x. So if 2x plus 5y, now I just have 5y equals 6. So if 5y equals 6, then I've got y equals 6/5, or 1.2. So that's my y-intercept, so it's the point 0, 1.2. Okay. Now if I want to find my x-intercept, goodbye y, that would turn to a 0. So 2x equals 6, therefore x must equal 3. So there's the point 3, 0. That's going to be my x-intercept. Okay. We're going to use this method to do a little bit of graphing. Okay, so if I'm trying to do this, graph 3x minus 2y equals 12 using intercepts, I'm going to go ahead and use my method. So 3x minus 2y equals 12. I'm going to find the y-intercept by covering up x. X is gone at 0. So I just have negative 2y equals 12. So if negative 2y equals 12, then my y-intercept equals negative 6. Okay, or I could say 0, negative 6. Okay, and if I try my x-intercept, okay, goodbye y, that's going to be gone. So now I just have 3x equals 12. So that means x equals 4. My x-intercept is 4. Therefore, it's the point 4, 0. So when I graph this, what I'm going to know is that 4, 0, I'm going to put that point on the graph, and 0, negative 6. Put that point on the graph, and then because this is a form of linear equations, it's going to make a straight line. So all I really need to do is find 2 points, and I can draw a line through them. Okay, so pretty convenient. I like it a lot. It's quick. Okay, oops, I kind of gave away the answer. All right, so we're going to graph 3x plus 5y equals 15 using intercept, and pretend I did not just do that. So there we go. 3x plus 5y equals 15. You're using your intercepts. I want you to try this one on your own. Okay, so you're going to look at your little graph. And I will cover up or make x and y both equal 0 and find it. Okay, do it on your own and then check. Okay, you should get this. The x-intercept is 5, because 3 times 5 is 15. The y-intercept is 3. 5 times 3 is 15. It should be a straight line diagonal going down, looking like that. Okay. Let's look at some horizontal and vertical lines. Okay, if I have this one, graph y equals 4, well, I don't have an x in there at all. So what's going to happen? I'm going to have the point y equals 4. My y-intercept is going to have to be at 4. Well, in every single time, y value is always going to be at 4 no matter what. So you're going to notice that when y equals 4, this is a horizontal line. Okay. When I'm looking at x equals something, x equals negative 3, well, this definitely is going to mean my x-intercept has to be at negative 3. And again, like that's negative 3, 0, but negative 3, 1 could be a point, negative 3, 5, negative 3, negative 3. Okay, you're going to notice an x equals a number is going to be a vertical line. Okay, so this is usually the hardest part for people, writing it in standard form using integers. So if you don't have standard form memorized yet, standard form says ax plus by equals c, and it's in integer form. So we're trying to, now we're not trying to get y alone. Right now y is alone, and it's in slope-intercept form, which is a great form for a lot of things, but sometimes we want standard form. So if I want this equation to look like this, one thing that I need to do is get x and y both on the same side. So I like them on the left. So y is already on the left. I'm going to subtract 2/3 x from both sides to get my x value on the left as well. So I've got negative 2/3 x plus y on the left, because they're not like terms, equals 6, which is on the right. Okay, now it looks pretty good because it's in something times x plus something times y equals c. The only problem is it says I need to use integers, and I have one number here that's not an integer, negative 2/3. It's in fraction form. It's not a whole number, it's opposite. So I need to get rid of that fraction. My personal technique that I like to do is just multiply both sides by the common denominator, because that will get rid of all my fractions. So I would choose to multiply both sides of this equation by 3. Okay, multiplicative property of equality, that's okay to use. Doesn't change my equation, it still will be equal. And use the distributive property here. 3 times negative 2/3, that will be negative 2x. 3 times y is just going to be 3y. And 6 times 3 is 18. Okay, this equation is in good form because it has ax plus by equals c. Okay, if you wanted to multiply the whole thing by negative 1 to get it a leading positive number, some people like that. 2x minus 3y equals negative 18, that would be okay as well. Okay. All right, this one I want you to try on your own because it's, I think, a quite important concept. I want to see if you can get it. So Try to write 1/2 y minus 12 equals 3/4 x in standard form using integers. And I'm going to show this on the next page. So 1/2 y minus 12 equals 3/4 x. All right, so again, if you don't know your form, that's going to be really important because it's hard to transform it to a form if you don't know what that looks like. So ax plus by equals c, so I want my x and y on the left and my numbers on the right. So I'm going to start out by subtracting 3/4 x from both sides. And I'm going to put my x first because that's how I like it. And that's the form, negative 3/4 x, that's a positive 1/2 y, minus 12 equals, now I have nothing over here, so 0. Okay. Well, now I want my number on the right, so I'm going to add 12 to both sides. And then I get negative 3/4 x plus 1/2 y equals 12. And I want to, I mean, it's good because it's ax plus by equals c now, but I can't have any fractions. So again, I like the technique I used last time, multiplying by a common denominator. 4 and 2 both go into 4, so I'm going to choose to multiply both sides of this equation by 4. 4 times negative 3/4, that's just negative 3, and we have our x, so negative 3x. 4 times 1/2 is 2, so we have a 2y. 12 times 4 is 48. So I see that negative 3x plus 2y equals 48. And now I'm good because I have it in ax plus by equals c form, no fractions, it looks great. And I could graph that by using my intercepts. Okay, so this time I want you to try this one on your own if you can. Can you write in the equation in standard form, again, ax plus by equals c, to model the number of hours you would need to work at each job to make a total of 130. So you're working some hours mowing lawns and some hours delivering newspapers, and you want to make $130. Okay, so I'm going to call mowing lawns X, and I'm going to call delivering newspapers Y. I mean, you could use M and N or whatever you want. It would be okay too. Okay, and when I think about this, how much money I'm making, if I mow X number of lawns and I'm getting, or mowing lawns for X hours, and I'm paying $12 an hour, I would get 12 times X for my lawns. If I'm delivering newspapers for Y hours and getting $5 an hour, I would make 5 times Y for newspapers. To figure out how much I would make altogether, I would do 12X plus 5Y, and I want to make $130, so I would say equals 130. There you have it, a lovely equation in standard form. Right there. Okay, we could find our intercepts, we could do a couple other things, but it was a nice way to write that type of equation where you had the two jobs. Okay, what I want you to think about, and I'd love you to be able to talk to me about this, when is standard form actually more convenient than slope-intercept form? Why do you think we might have more than one form? Try to come up with an answer or two and talk to me about it in class.